Welcome to solverfy.
In this question, it is about a mechanism that's being used in a riveting machine. It consists of a driving piston A, 3 links, AC, CB, and CD, and a riveter that's attached to a slider block B. At the instance shown, the piston A is traveling at a speed of 20 meters per second along this 45 degrees track. We will need to determine the velocity of block D. Okay. So in this case, we want to find VC first because D is linked to C. Okay. So to find VD, we need VC because there's a link between C and D. So first we need to find VC, and after we find VC, we can find VD. Okay. Okay. So we are given that VA is 20 minus cosine 45 degrees I plus sine 45 degrees J. And so this is 10 root 2 minus I plus J. Okay. Then because B is fixed, okay, so C is going to rotate, going to move at a direction that is perpendicular to BC. Okay. So this is going to be 30 degrees. Okay, this is VC. So, and the magnitude of VC will just be VC, okay, because we just need VC to find VD, okay. So from the diagram, okay, B is fixed. Okay, so VC is 90 degrees to RBC. Okay, so based on the diagram, VC will just be VC times minus cosine 30 degrees I plus sine 30 degrees J. Okay, so this is half VC minus root 3I plus J. Okay, so given VC, we can find because we have an equation that links A and C. Okay, through this relative velocity equation. Okay, VA equals to VC plus omega AC cross R, A relative to C. Okay, so this is equal to half VC minus root 3I plus J, and then omega AC will just be assume it to be positive for now, and then RAC is 0.3 cosine 30 degrees I minus sine 30 degrees J. Okay, then so continue to do the algebra. So this is what we have. Okay, the cross product will give us 0.15 omega AC I plus root 3 J. Okay, because K cross I gives J, cosine 30 is root 3 over 2, and the half is multiplied with the 0.3, which gets 0.15, and then K cross minus J gives I. Okay, and then we can group the terms together. So 0.15 omega AC minus root 3 over 2 VC I plus half VC plus 0.15 root 3 omega AC J. Okay, and then this is equal to 10 root 2 minus I plus J. Okay, so now we can compare components. So for the x component, okay, this is what we have, 0.15 omega AC minus root 3 over 2 BC equals to 10 minus 10 root 2. And then for the y component, okay, so this is 0.15 root 3 omega AC plus VC over 2 equals to 10 root 2. Okay, so we have two equations. Okay, so since we only need VC, so I'm going to eliminate omega AC. So we are going to have 1 times root 3 minus equation 2. Okay, so the term with omega AC cancels out. So we have minus 2 VC equals to minus 10 root 2 root 3 plus 1. Okay, so VC will just be 5 root 2, 1 plus root 3. If you use your calculator, okay, you get VC to be equal to 19.3 meters per second. Okay, now we have VC, we can proceed. So VC vector, it will just be half times 19.3 times minus root 3I plus j. Okay, so this is the vector VC. Okay, so back to the diagram. After finding VC, we can find VD. So we know that VD is going to move along the j direction. Okay, so writing down VD is equal to VC plus omega CD cross RD relative to C. Okay, so we have VD along the j direction is equal to 19.3 divided by 2 minus root 3I plus j plus omega CDK cross. So RDC is 0.15 minus cosine 45 degrees I plus sine 45 degrees j. Okay, so continue to do. You have 9.65 minus root 3I plus j. This is 9.66. Okay, plus 0.15 omega CD 1 over root 2 k cross minus I gives minus j, and then k cross j gives minus I. Okay. Oh, sorry. This is minus. Okay. So this is minus, and then so we have plus I minus j. Okay. Then we have minus 9.66 root 3 plus 0.15 omega CD divided by root 2 I plus 9.66 minus 0.15 omega CD over root 2 j. Okay, so comparing components, so the x component, so we have 0.15 omega CD divided by root 2 equals to 9.66 root 3, right? So omega CD will just be 158 radians per second. Then we are going to put this omega CD into the y components. So y components Vd is equal to 9.66 minus 0.15 omega CD divided by root 2. And so this is negative 7.07 meters per second. Okay, so the final answer Vd factor is minus 7.07 J meters per second. Okay, so this is the answer for this question.